Thanks for the overview, John. It's great to see Juju's progress and the value it brings to the cloud native ecosystem. John mentioned a path to get started with Juju and Charmed operators, but Daniela is coming up next, and she'll take you right down that road and help you create an operator for an application right now. Daniela, over to you.
Thank you, David. And hello, everyone. My name is Daniela. I am a software engineer at Canonical. Thanks for joining us today. I am going to be taking you through the first part of this session where we'll talk about Juju and charming concepts, and then we'll dive a bit deeper into the build and deploy process of an operator so that you can get a feel of what it is like to work with Juju. By the way, this is meant to be a hands-on session, so feel free to join us while we code. Now, that being said, in this slide, we have some instructions about how to set up a development environment. We're coming back to this in about 10 minutes. That should be enough time for installing and configuring things like Charmcraft, microcates, and Juju. Also, all the commands and code snippets we're using today can be found in the Operator Day 2022 gist and in the slides. We are sharing with you guys the link. Also, we have some repositories that we will be using. On the left, we have the template operator, and then on the right, we have the charmed operator code. We're also sharing with you the links. I'd also like to mention our charming community. First of all, we've got charmhub.io, where you find a collection of all the operators we at Canonical and the community have built, including the charm we're using today for our demo. We also have Discord, which is our community forum. And lastly, we host a Mattermost instance for the community at chat.charmhub.io. It is similar to Slack. It is a multi-channel instant messaging application. All right, so Juju, what is it? What can it do? So Juju is a charmed operator framework. It is composed of an operator lifecycle manager, which is a system that allows you to do application management across multi or hybrid clouds through shareable, reusable, tiny applications called charmed operators. Juju is also composed of an SDK, which is the set of tools to guide and package those charmed operators. With Juju, we can deploy, integrate, and manage applications across multiple KATEs or VM environments. We can also build complex environments frequently. We can manage apps and services across multi or hybrid clouds. And also, we can manage day 0 to day 2 operations at scale. Now, to understand how Juju really works, we have to define controllers. And a controller is the initial cloud instance that is created in order for Juju to gain access to a cloud. It is created by having the Juju client contact the cloud's API, and it is like any other machine instance in a cloud environment. So for instance, in Kubernetes, it is a container inside a pod, but it might as well be a Lexi container or a virtual machine. Now, the controller is a central management instance for the chosen cloud. It is taking care of all the operations requested by the Juju client to act on models, applications, and machines in our environment. You can see models as a workspace in which applications are deployed, but we'll define them in more detail later. Now, while all the controllers are essentially the same, there are 3 kinds of common configurations that you may find. So the first one is the cloud-specific controller, which has control over models from just one kind of substrate. So for instance, in today's demo, what we'll be using is a cloud-specific controller, which just talks to Kubernetes models. However, you can also find multi-cloud controller and add models from any substrate. Say the same local controller living in your microcates deployment can also talk to models hosted in any public cloud like AWS, VMware, GCP, Azure, etc. And then finally, there's a hosted Juju controller that we call JAS, or Juju as a service, which is a free-to-use hosted Juju controller provided by Canonical. In the previous slide, I mentioned models, but it makes sense to describe those in more detail. So models allow the logical grouping of applications and the infrastructure that work together to deliver a service or a product. Each of the blobs that you see in the diagram represent a charmed operator, which is basically an application. It could be WordPress, it could be Mattermost, PostgreSQL, or even a Kubeflow component like the training operator. All right, but what is inside an application? What is inside those blobs that we were looking at? On the left-hand side of this diagram, we can see the Juju CLI, which is the bit that we interact with. The CLI talks to the Juju controller using the API in the controller, and then the controller emits events to a Juju agent inside your application. That agent is always running inside your container or machine, it depends, and then that intercepts the events coming from the controller and decides which bit or bits of your charm code to invoke. This is what ultimately drives your application. We as Charm developers are responsible for writing those callbacks for the various lifecycle events emitted by the controller. Now, the dotted replicas that you see behind that application in this diagram illustrate different units of an application. When you scale applications, you get more units. One of the more important things about this design is that as you scale up your application, your operator is also scaling up. Compared to other K8s operators, for example, the charmed operator is always running right next to the application, which is really the best place to operate it because we won't mind about connectivity, network latency, and some other issues related to distributed systems. Now let's take a deeper look at charmed operators. And a charmed operator is all of the domain knowledge and expertise required to operate software that is distilled into nice, clean, maintainable Python code. We know that application code used in many enterprise use cases is open source, and many of these enterprises are using the same code to solve similar problems. So the question here is, why not share the operations code as well? So charmed operators, when they are packaged, they are essentially packaging the operations code and distributing that for anyone to take advantage of it. All right, so as mentioned, charms are ops code package, and Juju offers tools that allow you to manage common lifecycle events, such as install, configure, update, remove, and this is really something that most operators do, in particular K8s operators. But where our operators really start to come into their own is in their ability to specify day 2 actions. So we as Charm developers can specify different supported, let's say, commands. For instance, a backup action for our application, or maybe you want to add a new user or change that user's role. Really, the idea behind actions and day 2 operations is to encapsulate all the things a human administrator could do beyond the deployment of an application. Oh, sorry. And finally, we have the ability to integrate applications, which we know as relations. The idea behind relations is that Charm developers should know their applications and how they can interact with other charms, so that charms users can seamlessly integrate different applications. All right, so as you can see, charm developers do the heavy lifting to understand the business logic of an application, how best to integrate that application with other things, and how to automate everything beyond the deployment so that everything runs smoothly without the complexity of manual maintenance. Okay, so what happens when you deploy a charmed operator in K8s? By the way, we'll focus just on K8s operators for this demo. It is slightly different to how it works on bare metal or on a VM, but it follows more or less the same model. All right, so when you add a Juju model, what you're essentially doing is creating a K8s namespace. And then when you deploy an application, you are creating a stateful set with a single replica. That's a default. And then when you scale that application up, you're basically changing the replica definition of that stateful set. Now, if we take a look at what is inside those pods, inside that stateful set we saw previously, inside the pod, you get basically two containers, the charm container, that's the sidecar, and then you get the application container, the workload that you're trying to drive. The charm container is what the Juju agent, the charm container is what has the Juju agent and therefore invokes your charmed operator code. And the application container is any upstream OCI image that you could think of. Let's say upstream container image for MySQL, Mattermost, again, any Kubeflow component like the training operator. Now, the agent is able to control the workload container using a clean, opinionated, and very contained system called Pebble. What Pebble allows you to do is start and stop services, set environment variables, push and pull files, and other things that allow you to kind of manipulate processes running. All of this with no changes required to upstream container images. Pebble is lightweight, it is API driven, and it behaves similarly to S6 or Runit, and it is embedded automatically by Juju when it deploys an application. So basically, we use an init container to go fetch the latest version of Pebble. Then we create a volume mount inside your workload container, which automatically injects the Pebble binary into it. It overrides the entry point of that container, and then we instruct Pebble on how to start a workload in the container. And finally, the communication between the agent and the application is done through a socket that Pebble creates. All right, so why would you want to use the operator framework, given all of the things that we've discussed? The charmed operator framework enables you to write simple operations written in Python. Your operators will have a consistent UX and CLI irrespective of the application. So configuration, integration, data ops, everything is handled through the same Juju CLI. And then we also have a simplified way of sharing code and integrating applications. That is done through libraries and relations. Okay, so enough information. Let's see what we expect about this session. So what we're going to do in the hands-off portion of the session is we're going to initialize a brand new charm. We're going to handle some specific configuration. We'll define a day to action. And then, although covered in further sessions by my peers, we'll define charm libraries and integration to other applications. All right, so once again, there are two key repositories we are going to be using today. The one on the left is the operator template we use to create new charmed operators. And the one on the right is the sync charmed operator, which is the application we'll be interacting with today. Sync is a search engine that does full text indexing, and it offers a web UI for querying data. You can see it as a lightweight alternative to Elasticsearch, and it runs using a fraction of the resources. It's actually compatible with Elasticsearch API for data ingestion. And really, if you're using Elasticsearch just for ingesting data, using APIs and searching using Kibana, Sync is a great replacement for Elasticsearch. Again, to make things easier for anyone that wants to follow, we are sharing the links to a gist with all the commands and code snippets, as well as the slides. Also, we have created a set of branches in the Sync repository that include all the changes we will be discussing. So if you want to avoid copying, pasting, and writing a lot of text, you can just check out to each branch and see the changes as we go. Once again, here are the steps to set up the development environment. From now on, all the instructions assume that you have a microcrate cluster up and running, a Bootstrap Juju controller, and some tools installed like Charmcraft. By the way, I mentioned Sharpcraft before, but it is important to say that it is a CLI tool that we use to create, build, and publish charms. Sorry. All right, so let's start with the demo. And if you have cloned the repository already, for this part, we'll be using the branch called one-template. Now, if you clone the repository and change directories into that one, what you'll find is the tree that you can see here. What we have here is the standard templated tree of a charm. The first three files that you can see here, the contributing, license, and readme.md, those are pretty standard files to every single repo. We also have a tox.ini and pipeproject.toml, which are files that allows us to configure the automation part of testing and packaging, also standard to repositories. We also have the requirements.txt file, which is a standard Python requirement file that we use to declare and pin the version of any Python libraries required by the charm in runtime. You can also see the tests directory, which hosts unit and integration tests, but my peers will talk about this later in the session. And then we can find the charm-specific files. Let's start with the charmcraft.yaml file, which helps us instruct Charmcraft what is in the directory and how the directory should be built. We also have the config.yaml file, which contains the definitions for all possible configuration values supported by the charm. And then we also have the actions.yaml file, which contains the definitions for all the manual actions supported by the charm. And then for the last two files, let's go to the terminal. Okay, and then here in the terminal, what I have is, let me just check out to that branch. We have the same files. And then let's take a look at the metadata.yaml file. In the metadata.yaml file, what you can find is configuration information and identifying information. Here we describe the charm. I mentioned identifying and configuration information. So identifying information is used to describe the charm. Its author, its purpose, its description, its summary, as you can see it here. But we also have configuration information, and that is provided by the charm author to inform the Juju operator lifecycle manager how and where to deploy the charm, depending on the intended platform, if you have storage requirements, resources, and possible relations. So as you can see here, you can say you can specify that you need a container that is called HTTP bin, and it's linked to a resource called HTTP bin image. That resource is also defined here, and it's basically saying, go fetch this upstream container image. Now, we also have the charm code, and the charm code is basically a file that contains Python code. It is the default entry point for a charm. And the first thing that we can see is all of the imports from the operator framework. And then we have a class. This class is named after the charm itself, and it inherits from Charmbase, which has the right primitives that will allow you to interact with the events emitted by the controller, among other things. You'll notice here in the init method, all the self-framework observes. These are the things that allow you to observe all the events emitted by the controller. And then in here, we're also specifying the callback methods that will handle those events. Now, those callback methods have to be defined somewhere, and they are actually defined in the same class as the operator. So for instance, if we are observing the config changed event, we are tying that event to a config change method that is described here. And then you just have to define what that config change event handler or callback method is supposed to do. Finally, what we have here is some sort of entry point, which is used by the agent at runtime. All right, so that's it. To start our workload, the first thing that we have to do is edit the metadata and the charm code. And for that, I'm going to just check out to this branch to -specify -workload. And let's take a look at the changes in those files. So if we take a look at metadata.yaml, what we can see is that we have now a name, a display name, a description, and a summary that is very specific to sync. We have also specified a container. We're telling that this charm has a container called sync, and that container uses a resource called sync-image. And we're also saying that we should mount some kind of storage in that container. The resources are defined here. So we just have the sync image, which is just fetching, again, from a public repository. And we're also specifying some sort of storage that we'll use. If we take a look at the charm code, what we are basically doing is just renaming the class so that it's named after the charm, which is sync. We are, again, inheriting from charm base. We have the init method, and we're just saying that we want to observe the sync pebble ready event. And we're tying that event to this event handler. Now, this is a very interesting event handler because here we are modifying and setting the configuration of Pebble. Real quick, Pebble uses a series of layers for its configuration. This is what we call a Pebble layer. And in there, you can specify the processes that you want to run, the path of the command that you want to run, arguments to it, any environment variable that you want to specify for the process to run, and any relevant process ordering. So in our case, we want to run the sync binary, and we're specifying that as a command. And also we're specifying some environment variables, such as the admin user and the password. And that's it. If we leave it as it is and we build this charm using the Charmcraft CLI, we should be able to deploy the charm. So let's go ahead and do that. So to build your charm, you just have to Charmcraft pack, and you can add the verbose flag to it so that you can see things as they are built. So let's run that, and I'm gonna put this aside. And while we build this charm, let's see what is going on here. So what I have here is two tools that will allow us to kind of like debug and see what is going on with our charm. The first one is Juju debug log. And that is a tool that will allow us to see all the events that are being emitted by the controller. We can also see how our charm is responding to those events. So what the methods are doing. And in the case of an error, you could also see tracebacks and error messages there. This is a pretty handy tool when you want to really see what is going on in your charm. And then in the terminal below that, we have Juju status, which is basically an interface that will allow us to see the status of the charm, the number of units that you have from that application, the name of your application, which controller you're using, the name of your model, the cloud where you are deploying this model in these applications, and the status of all your units. Again, if you have an errored application, you can see that information there as well. Okay, so now as we can see, the charm is packed. And what we do to deploy this application, it's just Juju deploy, then the name of the application, or in our case, the path to the file of the recently built charm. And then we are also specifying the resource. Here, we have to specify the resource because we have to tell Juju from where to fetch the image. But in the case of a charm that is in charmhub.io, you don't have to specify anything. You just have to Juju deploy and the name of the application. So let's go ahead and hit enter there. And this is saying, yeah, I'm deploying the sync Kate's application. And then here on the left, we can see that something's changing. We can see that the agent is allocating, the workload is running, and then it changes to maintenance because maybe it's doing something else. And then it changes to active. Now, we can trust the Juju status output and see that the thing is working. But since Sync actually provides us with a web UI, what we can actually do is go ahead and open the web UI. So to do that, you just have to use the unit IP address and this port, and we can see that it is actually working. Now, if we go back to the charm code here on the right, we specified some environment variables that define the admin user and the admin password. So if I go ahead and use that, I should be able to log in. And here it is. Our application is working, actually. Great. So let's go back to the slides. Okay, we have seen this. And let's take a look at actions. As mentioned before, Juju is really good at managing day two operations like maintenance or operation tasks. And in Juju land, that is achieved using actions. Actions are methods defined by a charm developer designed to be invoked by an administrator against a deployed charm. So an administrator through the CLI against an application that is already there. Right, so the first thing to be able to use actions is to set up the action in action.yaml file. In this case, we're saying a very small action which only retrieves the admin password so that we're able to log it into the web UI that we were looking at. Okay, so as mentioned before, actions are really just methods that we can define, and those live inside the charm code. In this case, as you can see, we have the onGetAdminPassword method, which will retrieve the admin password if it exists, or else it will create a new one and return it as well. Right, so if we go back to the terminal, and check out to the branch called 3-actions and check on the actions file, we can see that we are specifying the name of the action and a brief description of that. If we open the charm code, we can see that now, besides the sync pebble ready event that we were observing previously, we're also observing a new event, an event that is actually named after the action that we just saw. And we're also specifying the callback method that is attached to that action. So let's take a look at what this method is doing. And as I mentioned, it is just returning the admin password to be used in the web UI. Okay, so once again, if I want to build this application and see the changes, what we have to do is pack the application again. And while this is packaging, what I'm going to do is actually remove the existing application. So let's remove the existing one. And what we're actually doing is removing the existing application because it has a storage attached to it. And since we are generating new passwords, we don't want to use or reuse that storage. All right, so as you can see here on the left, we cannot see the application anymore because I just remove it. And let's go back to the other terminal. It's not finished. And let's wait for it to finish. Again, you can follow what is going on with the charm using Juju debug log or Juju status. Okay, so now that the charm is packed again, what we have to do is deploy again and wait for that to happen. Once again, we need a web browser to interact with the application. Let's wait for it to be active. That should do it. Okay, we can see the web UI. This is working. Everything's fine. And to put things into action, let's run the action as it's shown here. You just have to Juju run action and then specify against which application you want to run this action. In this case, it's just syncates. And then you specify the same name of the action that we defined in the actions.yaml. And you can also wait for it to respond. So let's hit that. And that should retrieve us this new password that we can use here. So if I again do this and paste the action, I am able to log in and see the UI and see that it is working now with the new password. All right, so let's go back to the slides. We just saw this. And let's talk about relations and libraries. Although we are not going to cover this topic in this session demo, like we are not defining relations and libraries, it's important to define what they are, as they will be used in further sessions. So relations provide a means to integrate applications and enable a simple communication channel. So let's look at the model deployed in the diagram. Each of the operators that you can see there are doing one thing and one thing only. They only care about the business logic behind their own application itself. Now, the lines connecting each of these operators are the integration between those applications. And that is what we call relations. So what happens here is that you could deploy each applications independently and then say Juju relate application A with application B. So in this case, what we are looking here is some Kubeflow applications. So what we can say is Juju relate Istio to Jupyter UI. Now, when you tell Juju to relate two applications, it is all done through propagating events, as we saw in the many examples, from the Juju controller to the individual charms. In this example, we have PostgreSQL and Mattermost, and we can see that Mattermost requires PostgreSQL, and that actually PostgreSQL provides the interface that Mattermost requires. By the way, these relations are defined in the charms metadata, and as we saw previously, we can just Juju relate application A with application B. Now, in the case of Mattermost, it won't show up as active until the relation has been provided. And then after that, everything's green and everything's working. Now, charm authors need a way to easily share and reuse logic, and libraries help solve that problem. They are essentially a way of sharing code to other charm developers, and they tend to be single files and don't require any additional build or distribution infrastructure. Again, without going into much detail, this is how a library would be used inside the charm code. In this example, we are integrating our existing sync charm with the Grafana library, with the Prometheus library, for adding observability capabilities, but we'll discuss later that in the CIME session. All right, so let's do a brief recap of this. What we did in this session was we initialized a brand new charm using the template operator, and then we defined a configuration with Pebble layers. We defined a day2 action, retrieving the admin password to access the web UI. And then we introduced more or less what are libraries and relations. Once again, the charmed operator framework enables you to write simple operations code written in Python. It provides us with a consistent operator UX and CLI for all operators. And then we have a way of code sharing and integrating our charms. Then once again, please join us in the multiple community spaces and communication channels that we have: charmhub.io, Discourse, and Mattermost. Especially join the conversation in Mattermost, where we'd be answering questions or comments on all that happens during this session. And that is all from me. Thank you very much for joining us today. Coming up next is CIME, taking us through the wondrous world of observability. And all right, Dave, back to you.